So yeah, the book also has information on throwing and picking up objects. That's basic scripting and the 3D physics system. For that, they don't list out rigid body specifically, but rigid body and colliders are part of the physics system. And so that's what they're going to discuss in Chapter 7. Chapter 8 is the animation system. That's the animator. That was also listed. Where did I put the animator? Did I forget about the animator? Oh, no, I put it in the very beginning right here. There's the animator. Yeah, the animator is a pretty powerful tool. And so they looks like they spend even 2 chapters on going over how to do animations. Usually you have an animator specifically do that. When you're working on a game, you typically split the project up into pieces. You have a person who does the graphics and animations. You have another person who does the sound. You have a person who does the programming, and then you have another person who kind of, maybe designs the mechanics of the game and is responsible for the testing as well, to make sure that what is being built is kind of what they had in their minds when they designed the game to begin with. Chapter 10, learn how to add characters. That's a more complex feature. We won't get in that today. If you guys are interested, maybe we'll go over the character rigging next week, where you basically add a humanoid to a model. It's usually easiest if you download an asset. We're not going to create a human character on our own. And the thing is, a lot of the models that you find on the asset store, they already have the bones and everything, so that it all works automatically anyhow. The audio system, we actually didn't do any audio stuff yet. Maybe we'll do that today. It's pretty straightforward. Adding audio is very easy in Unity. Unity supports 3D sound, which is cool. So if you've got a 3D game and your sound is coming from a creaky, door or something, and you're not close to the door, you won't hear it. But if you're right on top of the door and you're opening it, then it's you'll hear it loud and clear. Chapter 12, building an interface. My guess would be that covers more of the UI canvas. And this book is new as well. I think it came out in 2019. And it's by O'Reilly. O'Reilly is one of the largest technical book publishers in the world. They make all kinds of interesting and useful textbooks that are kind of on the cutting edge. A lot of the books that they publish are new technologies. They've been around since the beginning of the internet. They were one of the first companies to start publishing books on how to build websites and how the internet protocol works. The person who created the organization, Tim O'Reilly, he's a big proponent of the open source movement. He's a really big, open source guy. And so one of the other things that drew me to the book is just the pictures that they use are useful and relevant. They go over the inspector and all of the things that we've kind of gone over, what metadata files are. We talked about that, I think, 2 classes ago. We went into children and parents pretty extensively at the end of the last class period. Was that clear for everyone? We kind of went over it quickly, not too quickly, but it's a little more technical, I guess, than some of the other stuff, the parenting and unparenting of game objects in your hierarchy. But yeah, more or less, I hope it's clear now. So yeah, the book should be a really good reference to follow along with. Yep, we've talked about mesh renders. Yeah, so today I was thinking we could start off. We're going to create a new, did this save? I hope it saved. I think it auto-saved. Google Docs does the auto-save. I was thinking we could do a 3D first person, maybe not a shooter, but a first person move around and be able to manipulate objects in your scene type game. So let's go ahead and get a new project open here. Yeah, this is going to give you guys a little practice. Go ahead and create a flat plane and a ball, and maybe some walls, I would say, as well. So you go in here and you go to 3D objects, and yeah, we can create our new plane or quad. Don't forget to rotate it by 90 degrees in the X direction. We could make it really just huge. This will give us lots and lots of space to make walls. I'm not sure if anyone looked at the tool I recommended last time. Gosh, I'm drawing a blank on the name of it already. It was in here because it's part of the standard assets. ProBuilder. This one's pretty good. For today, we're just going to make some walls. We can even give some better names because we're going to have quite a few objects, game objects in our scene now. So we'll call this the floor. And then we'll create some new game objects. This is just kind of giving you more practice working with the editor itself, using the handles to manipulate the different game objects in your scene. Let's make our walls, let's see here, 10 and 10. That's a pretty good wall there. If we want to duplicate it, it's just Control D is the hotkey, and then we've got a wall here. You know, we can take that wall and we can, we're going to be rotating it around the y-axis. You know, this is a very easy way of designing a level right here is with these walls. Use the Alt key if you want to rotate around whatever is highlighted. Let's call it wall. Trying to give a better name just so that we don't get confused later on with what's in our scene. Let's duplicate and make another one. And duplicate and make another one. It's just basically walls that we can go around and bump into. The most important thing we want is the capsule. Capsule. Could be a ball, but capsules look more like a human, right? This is a capsule collider is usually what you use if you want to detect collisions and not use too much computational power. And so now one of the things that we want to do in order to have it the camera move around with our player is we want to use this parenting of game objects and actually make the main camera a child of the player. And one of the other things we need to do is make sure that that camera is actually on the player itself, so that it looks like that. So when I hit play, this is what the player is looking at. It's a little hard to see from there. Let's pull our camera kind of to the front. Might even be easiest to do 0, 0, 0. And down here, it gives you kind of a camera preview. If you've got a camera selected in your hierarchy, it will give you a preview of what that camera looks like. Let's now put a move script onto our capsule collider. So there's two ways of doing this. You can either come over here and you can create a new C# script here, or you can come over here and you can do it from the inspector. Either way, we want to have a move player script on our player. And then once we've got that, let's come over into Visual Studio and add some functionality to that move player script. Any ideas where we're going to put the code inside of which function we're going to put the code in our move player script? We're going to want to put in update because update's getting checked every frame. If we wanted to, set the position of the player when they start the game at a starting spawn point or something, we could use start. We could also use awake. Awake is another Unity mono behavior function that gets called right when you start the application. But for our purposes, we're going to want to put our code in here. Yeah, if we are pushing the down or up arrow key, we want to move forward. Get key down. People are familiar with this. Let's just go ahead and write the functionality to move our player. I actually wrote a lot of this code on Tuesday, so I might even go back and grab that code and just throw it on the Slack so people don't have to spend so much time typing it out. Let's see here. I put it in day 5. I think I had moved cube. We were moving a cube last time, but here's our code from last time. I'm going to go ahead and just copy this into our Slack, so if people don't feel like typing out the movement, you can just copy and paste this into your update function. And don't forget, to add the rigid body. Otherwise, it's going to, our code here, it looks for a rigid body on our player, and if it doesn't have one, it's going to fire a null reference. So let's go ahead and come back over to our editor and make sure that we've got a rigid body on our player. I want to stop now, make sure we're not going too fast. If I hit play, I think we should be able to move our character around now and it'll kind of look and feel, oh, we're falling over. What are we doing? I think we're rolling on the ground. This would be my guess. If we came back to the scene here, looks like we are rolling around in space. So one way of fixing this is the rigid body you can actually lock in different directions. It's called a constraint. So in order to prevent our capsule from falling over, we're going to want to lock the rotation of the X and Z, I think, might be X and Y, but X and Z, so that we cannot fall over. See, now if we move in our game, shouldn't fall over anymore, and we can actually, oh, looks like we ran off the level. But yeah, it'll prevent your capsule collider from falling over because it's spherical on the bottom, and that's what allows it to move fluently. If we were a box or something, that does not slide very well on the surface, and so it's better to have a capsule or a sphere collider where, here, let's open up our capsule. You can see the little green lines whenever you've got a collider opened up and selected. You can see that it's round on the bottom, and that allows it to move smoothly. If it were flat on the bottom, it doesn't work very well. So yeah, if we go back, we can go back and forth. Oh, we bumped into the wall. I really get spun when we run into the walls. And so, yeah, our camera is kind of small. I think it's a Unity thing. It's supposed to be at 1.5 scale. If it's zoomed out, and I guess I didn't really talk about these handles that much. You can mute audio, or you can maximize the game whenever to the screen when you hit play if you've got this selected. What is this last option? I forgot what the last one is called. Stats. That's used more for optimization purposes. It gives you information on your draw calls and information that the processor is giving about the graphics card and the memory management. I usually don't use this too much. And then everybody's familiar with gizmos by now. Gizmos show you little hints and things. You can have gizmos in your game view now. That's interesting. It used to be only gizmos in your scene view, but it looks like you can show gizmos in your game now as well.
How do you support diagonal movement?
Diagonal movement, you'd probably push 2 keys at once. There's a number of different controllers. There's even a built-in Unity first-person controller package, I think. At least there used to be. Camera. Unless they merged it with the cinema machine, which let's try doing a search for camera. My guess would be that they merged it into the cinema machine, but Unity, it does have like a default first-person camera where it's basically a prefab. Let's do a search real quick on the asset store. First person controller. We're kind of doing it from scratch right now. You don't have to spend $100 on it either. Where is their free one? Hey, Taylor, can you mute your line? Getting some some feedback. There was one that Unity put out. I don't think this is it. Although it has over 11,000 5-star ratings, so this is probably not a bad one. I just, yeah, this is going to give you a lot of the things that you need because it's even got sprinting built in and a lot of other functions.
Apparently, to do diagonal, you have to add your results together. So when it comes through, if it checks for W, you add the forward result, and if it has the top, it would add the top result, and then they transform together. It's not. I mean, you could do an and maybe.
Yeah, there's a couple of different ways of doing it. Yeah, camera controllers you can make them as complex or as easy as you want. A lot of the original first-person shooters didn't even allow you to jump, but Unity makes jumping very easy. And so, yeah, it looks like this package even has head bob. This seems like a pretty good one. They even update it often. It seems like it was just updated a couple of days ago. Yeah, if you can find free assets and things like that, they're usually yeah, it's better than starting from scratch. I kind of just wanted to start from scratch to give you guys a little more practice creating new game objects and new primitives. But yeah, let's hit play again. This is kind of what it looks like from the game view. If you wanted to move the camera, behind the player a little bit, you could also do that. You just take the handle and move it back, and now you can see your character. If you tilt it down a little bit in the Z direction, you get kind of like, oh, no, I apologize, not Z, in the X direction. You get kind of like a third-person camera here, and you can actually see yeah, what happens if you hit that wall, man. It really spins you good. We would, I think, want to add a little bit more what do they call it? There's something that absorbs the material or the collision so that it doesn't bounce off so crazy. I'm trying to blank now on the name of that. In Unity physics, it's called tactile material. I think it's called a physics material. It is called a physics material. Yep, this is where you can set the bounciness and the friction of your objects. We were running into the wall and it was spinning us and doing all kinds of crazy stuff to our character. If you want it to not go crazy like that, you can create a physics material and you can put it on any game object, basically. It's just another component. Physics. Material?
Hey, I seem to have a bit of a problem with something.
Yep.
So when I hit play, the main camera kind of just drops to the ground, despite freezing the rigid body.
Okay. Let's go ahead and take a look. Why don't you share your screen real quick? Yeah, we'll all kind of troubleshoot collectively and see why it's behaving the way it is. All right. So it looks right. So when, or at least it's in the right position. You've got, I think your constraints, you want to lock the rotation, because I'm pretty sure your, did you lock it in the two directions? It looks like you've got the rotation and the, what is that other one? It's hard to read your screen with the resolution. Position, yeah. You don't want to lock the position. You just want to lock the rotation of the X and the Z.
All right. And then
and now it should be good. Now it'll stay upright.
It fell out again. Oh wait.
Go ahead and click on the camera. Did you add? What are those components? It looks like you have a rigid body on the camera.
Yeah, for some reason it threw an error when I ran it and said I had to have a rigid body for it.
The problem is when you add a rigid body to the camera, it gives it gravity. And so the reason why it's dropping to the ground is because you've got that. And I think it's also because you put a capsule. It's telling you need a rigid body because you have a capsule collider on your camera. And you don't need the capsule collider on your camera. The capsule collider is on your player.
Okay.
In some cases, especially if you've got a camera that you can control, not with a player, but like orbiting around things, it's good to put a little collider around your camera. We actually do that in Space World because we don't want, you can orbit around the planets, and when you're orbiting around the planets, you don't want to orbit through the planet. And so it's good just to have a little collider around your camera. If you don't want your game object to be affected by gravity, but you still need a collider and a rigid body, here, let me share my screen again.
Although, like it's still throwing me the error that that the camera needs a rigid body.
Did you put the move player script? It looks like you put the move player script on your camera instead of your player. So go ahead and you can cut and paste that onto your player. And we could even add, additional debug codes that help you out. Here, let me share my screen again. For example, if we were to come back over to our script here, you can add a try catch, for example. Are people familiar with this? This is how you do error handling in C#. You know, pretty much every programming language has some kind of error handling where, yeah, you catch an error. And so down here, if we were to get a null reference, it will come into this catch block, and we can say debug.log error. There is no rigid body on. And how do you guys think we would get the name of the game object that this script is on? We can just do lowercase game object, which is yourself, the game object that you're on, and it has a name. And so if we were to move our move player script over to our main camera here, move it here, and we hit play. When we hit an arrow key, it now warns us that there is no rigid body on main camera. And so let's go ahead and move that component back over to our player where it belongs. Yeah, very good. Is kinematic is the checkbox that you use, or you can just shut off gravity. There's two ways of turning off gravity. Is kinematic means it basically never moves. You can't, yeah, if you have is kinematic on, your arrow keys won't even change it. Is kinematic means it is basically you locked the rotation and position. It's basically the equivalent of having all of these blocks checked. You know, it means that it's not moving at all. Let's go ahead and turn back on our thing. We were adding a physics material. Yeah, for some reason, assets, create physics. Where do they move it? Physics material here. And this is where you can set the bounciness and the friction and everything. And yeah, then you could drop it on your walls. I think it needs a rigid body, maybe. Huh. It's being kind of fussy. To create one, then drag the physics material onto the collider. It's the physics material itself is not inheriting from mono behavior, so you can't just drop it onto a wall. Yeah, it's actually more like a scriptable object is what it is. So over here, let's get rid of our rigid body. Our collider has, yeah, the material here. Usually it's blank, but if you want to add a physics material, you can go ahead and drop it on there like that. And if you have multiple game objects and they're basically the same or they have the same properties, you can actually hit Control or Shift and do multi-select. So the multi-select works really quite well in Unity. So now when I drop this physics material onto here, it assigned it for both of these game objects. And so Yeah, I didn't really change my physics material around, but if I changed it here, it would change it for all of the walls, because this is the physics material that's assigned to all of the walls. Bounce, let's say minimum. And so now I think when we run up against the wall, it shouldn't spin us as bad as it did. Yeah, it's not spinning us nearly as bad as it was before. Yeah. Let's go ahead and add a sound so that whenever you run into a wall, it makes a sound. And we'll use a similar function. Let's use the on collision function that's built into mono behavior so that whenever you run into a wall, it makes a sound. Let's go to Google and find a good thump sound. Or maybe what's anyone know a good sound repository offhand? Sound repo. Because this does not seem like freesound.org. That's maybe a good bet. Search sound thump. Heartbeat, or what's this one sound like? That one's all right. Thump on the floor. Here, I'll save this. No, not HTML. Oh no, it's not going to let me just download it. One good free software out there for audio stuff I use frequently is Udacity. It's free. You can just hit record and come over here and yep, there is our thump right there. You can use this to record, anything on YouTube basically, but yeah, we don't want that whole audio clip. We would just want this little bit. So let's grab this, copy, and paste it to a new one. And then it can export. You can export it as a whole bunch of different audio file types. MP3 is the most highly compressed, and it doesn't lose very much audio quality. So I'm gonna thump, and I will post this MP3 to our Slack so everyone's got it. Unity's smart. Unity can handle MP3s. It can handle WAV files. It can handle a whole variety of different types of sound. And so yeah, there's our thump right there. Let's go ahead and drop thump into our project. It's easy as just dropping it into our project. Let's put the thump on our player rather than putting it on every single wall. You just drag and drop it. It's a component. Inherits from mono behavior. You can even, if you wanted to, do crazy stuff to it. If you want to manipulate it more, you can increase the pitch or decrease the volume. We're not going to want to play it on awake, and we're not going to want to loop it. Basically just want this audio source to play whenever we hit a wall. So let's go over to our move player script, and we could create a brand new script called run into wall if we wanted to. You can really pile as many components onto a game object as you want. But for this purpose, we'll just, since it involves a player moving into a wall, yeah, we'll put it on this one. So on collision, enter. Anyone have an idea? Give you guys a few seconds. It's pretty easy. We just get component. We're looking for our audio clip. Where is it? Audio source. I'm pretty sure it's audio source. And this stuff you just kind of, learn over time and by going through the book and the documentation. And if you want to do something, then Unity's probably got a way of doing it. It's just a matter of knowing what to use. In this case, it's an audio source component. If we wanted to see that, here's the name right here, audio source. The audio clip is something different. If we wanted to add an audio clip, audio clip seems to be something entirely different. You can use F12 in your Visual Studio environment, and it will take you to the script itself. Seems like audio source actually doesn't inherit directly from mono behavior. It inherits from audio behavior, which my guess is that inherits from mono behavior or behavior. Yep. And audio clip is something different. This inherits from object. So I'm sure this also plays sound, but the audio source is just easier because this audio clip didn't have a play function. It didn't look like. It's it's just easier to use audio source because we have play. Really, function. So now, if we come back over here and we hit play and we run into a wall, we hit the ground, and so that's why that first thump happened. Ran into a wall, ran into another wall. You can hear, every time you run into something, a new, we're spinning. And since there's not really anything that's to stop us from spinning, we would probably end up spinning indefinitely. If we wanted to prevent that, we would have to put something into our move player controller, or we would have to change our collider around. It looks like it's actually slowly stopping. The physics engine had some kind of resistance, probably from the floor itself. The floor causes friction here, and so that's why our player finally quit spinning. But does anyone have questions about what we just did, how we added this audio source to the player, and then we came over to our move player script and we put in this line of code that so whenever we run into something, we play the audio source that is on our player. If move player wasn't on our same game object, we would want to have a reference to that. So if we wanted to put our audio source on a different game object, we could come over here and we could do public audio source, and we could call it thump sound. And then when we come back over to our inspector, our move player script now has the thump sound. Normally we drop this in here. We've got some questions here. Do you mind going over configuration? The rigid body, oh, that was from a little while ago. That's what that beeping is my headset is low on battery, which is not good. I'm sorry. Let me think here. How am I going to do this? I've got an iPad. I apologize. Been using my headset a lot today, and it's about to die on me. 1 second.
Can you guys hear me? Let's see here. Good. So, yeah, it looks like the microphone on my iPad here works. Good. The problem is, I don't know if I can hear you guys here. Let me turn this up. Can someone say something real quick? I want to test to make sure I can hear you guys.
Hey, can you hear me?
Good. No, we've got an auxiliary microphone, and yeah, no, this will work.
Yeah, there's also an issue I was having where the code wasn't compiling.
Okay, did you get it compiling now?
No.
Okay, do you want to share your screen again real quick, and we'll take a look and troubleshoot why it's not working? All right, let's see here. What's the error message? Again, I can't really. The resolution is kind of low. What does the error say?
The error says only assignment, call, increment, decrement, await, and new object expressions can be used as a statement.
Okay, it looks like, yeah, if you go back over to Visual Studio, it's telling us there you have to add parens behind the play, because play is a function, and you're kind of treating it like a property. So go ahead and put parens behind it, and then you should be all set.
All right.
All right, very good. All right. So we've got our audio sound. Did you guys see how I did that? How I added the thump sound property to move player, and it was blank. And if I wanted to get the thump sound, you drop whatever game object is in there. So the wall wouldn't go in there because there's no audio source on the wall, but because our player has an audio source, we can drop player into there. And that's how you get that to be assigned. You know, if we moved our audio source to somewhere different, say we moved our audio source to our main camera, might not even let us. Let's copy component and paste component is new. Now we've got our audio source over here, and yeah, say this was here. I think if you remove it, it should, yeah, automatically set it to missing because we just got rid of the audio source that we were pointing to because we moved our audio source over to our main camera. So now if we take our main camera and drop that here, it knows, it's smart enough to know that, hey, there is an audio source on the main camera, and I'm going to play that audio source whenever I hit a wall. And so, yeah, again, we could hit play, same functionality. Ooh, we are getting a null value. Does anyone know what was wrong? Because here we're doing get audio source, but there is no audio source on our player anymore because we moved it. Instead, we want to use our reference. We want to use our thump sound because we're going to be playing our thump sound instead. And you can overqualify these things. You see how I got rid of the get component? We were able to get rid of the get component because it knows already that we are an audio source. But Unity actually doesn't care if you add extra stuff, so you could do get component audio source again, and it is still going to work just because even though thump sound is an audio source, it inherits from monolith behavior, so you can still use the get component function. As long as you are a component, you can use get component to get any other component that's on the same game object. Does that make sense to everybody? It's kind of, yeah, important. At the same time, yeah, any component you have could also get game object. Get component and get game object, are two very important things to know, and transform as well. So, yeah, so now when we run it, it shouldn't be throwing that null source anymore because we're referencing the thing the right way now. Very good. So we've got another half an hour or so before Chris has to drop off. Let's come back over here to our list of things that we want to learn. We've gone over most of these things. The only other things we haven't gone over are the scriptable objects. I need to find a good example of that. Scriptable objects are another one of those things where it's better if you go to the asset store and start out with kind of a base as opposed to completely starting over from scratch. Just because, yeah, scriptable objects fit within a framework. Usually you have some kind of component, and then you drop the scriptable object onto the component. And the best example, I guess we did kind of even go over it today, was this physics material. This is a scriptable object essentially. It's a material that the collider is expecting. It's not necessarily required, but you can drop it on there and it will alter the physics property of that particular object. And so you can customize objects that way. I showed you guys how to do a third-person camera as well. The first-person camera, you basically put the camera right on the player. If you want the third-person camera, you just drag that camera back and up a little bit and point it downwards in that direction. We've got the camera expanded here. It will show you the preview as well. Let's go over the camera. There's a few more properties on here that are important. If for some reason you're not able to see stuff, say you've got something really, really close. There's this property called really, really far away. Called clipping plane, and the best way to kind of describe clipping plane is the region in which you can actually see stuff. If you imagine like a pyramid, four-sided pyramid, frustrum is what they call it. It looks like this, where you will only see objects that are inside of this this region. And so usually your near clipping plane is very close. You can even set it to 0, I think, and that means anything that's in front of you, you will see. If you want to see things really, really far away, you can turn this up to really, really high, and you will see everything that your camera would see. But sometimes you don't want to show things that are really right in front of the camera because they can block your entire view. Say you've got something right in front of your face and you don't, you still want to see kind of around that thing. That's why the default near clipping plane is something small. I think it was like point, what is it? Let's create a new camera. Yeah, 0.3 by default. Just because if something's really right in front of the camera, you don't want it blocking the whole camera. We talked a little bit about the point of view as well last time. This is where you kind of focus in on something or zoom out. 60's the default and is pretty good. But if you want to add some kind of function where you would be looking through a telescope or something, you can adjust the field of view rather than changing the transformed position of the camera. The Viewports Rect is used to make billboards, or if you want to make a multiplayer game where you have multiple screens on the same screen. So if you have a 4-player game and you want to show all 4 screens on the same screen, kind of like the old 007 games on Nintendo 64, or any Mario Kart games where you're showing 4 different players on the same screen at once. This Viewport Rect is what you want to use. And it's used to adjust the size of the camera on the screen. The depth is used more for if you have multiple cameras and kind of different layers. This is at a depth of -1 by default, because a lot of times you want your GUI, you want your heads-up display to be on top of everything. You don't want your 3D objects or your 3D world on top of your menu system. Usually it's the other way around, and so that's why they have this depth property on the camera that's useful. And the culling mask is really, how you handle the different layers. We talked about that a couple of weeks ago. And then there's a few other properties. Usually if you hover over the properties, they give you an idea. The occlusion culling means that objects that are hidden are not rendered. This is kind of used to save memory. You know, if something goes behind a wall, you don't necessarily need to render it because you can't see it. And so this is kind of an optimization function that's built into Unity. Usually you want to leave the occlusion on. Maybe in some weird cases not, but yeah, it's there for optimization purposes. Some of these properties I haven't even really used. They're probably, for making your scene look really good. If you've got fancy lights and fancy shaders, then you can probably do some fancy things with your camera as well. Those are kind of outside of the scope of this class. This is more of an intro to Unity and not a how to optimize your graphics in a Unity game. You know, if you're a coder, you're not even going to be working on that stuff anyhow. That's something that is usually performed by, the graphic designer, or if you're on a bigger project, usually you have a level designer, and the level designer will be responsible for making sure all of the lighting and shading is set correctly. That person might not be a modeling specialist or a graphics specialist, but they know how to come into Unity and they know how to set up the level and they know how to make all of the lighting look really good. If you wanted to add music to the game, all you'd have to do is check the play on awake button and the loop button, and that basically does your background music. We could do it now, and we would get a thump, 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 thump. That's our. It's like we're at the club. Anyhow. Let's see here. What else do we want to go over? Let's go back and do a little bit more with canvas and layers. I think I said I was going to do that last class period, so let's go ahead and work on a heads-up display so that we can show information about our game. So if we right-click and we go to UI and we go to text, notice that it put it up here and it's kind of a weird size, and you'd think that that would be really weird, but it actually looks appropriate here in our game view, and this is because it's using a completely different camera. It's using the canvas camera. We can take the text then and move it around on our screen. If we want our time, we can put it down here in the corner. And let's create a new script called time on our text box. We had done this once before, but let's do it again just to make sure that everybody is kind of up to speed with how the canvas works. Time. Let's call it show time. I think time might be a special word. Sometimes, there's special Unity words that you just don't want to use because, the compiler will interpret it the wrong way. So now, if we want to get that text component, all we have to do is to get component. I think it was called text asset. And then the text. And we can do system dot now, or datetime dot now. Dot toString. Sorry, this is, if I'm going too fast, this is really, yeah, this is right out of a C# or Java playbook where we're just getting the, whatever the system time is right now. And we are setting the text. It is not, I don't think text asset is it. It's actually called just text. Text asset is a different thing entirely. And I think it's complaining because we're not using the Unity UI. If you see these little squiggly lines, it means there's a compiler error. And usually the compiler will suggest potential things that you did wrong. And it looks like we're not using the Unity UI package. It doesn't include it by default. It only uses the Unity engine by default. So any class where you want to manipulate UI code, you have to include this Unity engine package. You could also, instead of using the using, you can move that code here as well. Likewise, if we wanted to not have to write system, we could do using system. This is how programming languages use packages. So this should work now where when we hit play, we're going to be able to see our current system time down in the corner there. Let's go ahead and add 4 buttons to the screen. And those buttons will be arrows that move our player. So in addition to being able to use the keys on the keyboard, we want to be able to use on-screen buttons to move our player. I think that's probably a good exercise. Why don't you guys go ahead and take 5-10 minutes and create 4 buttons on your canvas. And those buttons will be up, down, left, right, and they will move your player. Yeah, we'll reconvene here in 5 or 10 minutes and make sure that everyone is able to do that. Okay, was everybody making headway on the buttons? Were you able to at least get the buttons on the screen? And in position and triggering with at least like debugging commands.
Yes, so I'm having one issue.
Yep.
Where so I'm trying to initialize like a line break with the UI canvas, but for some reason it doesn't actually show up. Like it'll show up in the game despite actually showing up in the text.
Dungeon Master.
It's like the with the like despite it showing it up in the inspector.
So the line break shows up in the inspector, but not in the game itself?
Yeah.
Let me try real quick. I'm not able to reproduce that. Do you want to share your screen again real quick?
Sure.
It might actually end up being a different property, perhaps, as well.
All right. So yeah, here's so yeah, there's the line break, and when I hit play,
Let's see here. Do you have dash line or system.newline? I think is the best way of adding a new line.
huh? Oh, specifically for the UI.
System.newline.
How is a new line put in again?
It's where is my syntax here? Environment.newline.
Ah.
And the vertical overflow is actually set to truncate by default. So that is probably what's happening, is that it's just truncating it. If you change the vertical overflow to overflow, then it will not cut it off.
Right.
I think
So-
yeah, what's probably happening is that it's so long that it's wrapping it horizontally, and so you have vertical lines, but then even in the vertical line section, it's cropping it is what it's doing. It's truncating it rather than allowing it to flow outside of the text box. Another way of fixing it would be to make the text box larger. If you set your width and height up at the top of the game object inside of the Rect transform component. If you make the width and height bigger, I imagine your text will show up.
For some reason, a system.environment isn't. Oh wait, hang on. Environment.newline.
Put system in front of it. System.environment.newline. I think I had a using. Yeah, there you go. I had using system up above, and
For some reason, it's still saying environment.newline, isn't it?
no way. Go up, hit play.
Oh, it's
What is there? Double click on the error again. New line. I think you get rid of the parens, right? It's new line is more of a static rather than a function. It's not a function. Now
nice.
you should be all set.
Oh, okay, thanks.
Okay. Yeah, we're coming up on 7 o'clock here pretty quick. Not sure. It looks like we might have already lost Chris anyhow. Taylor, did you get the? How far did you get with the buttons? You guys want another 5 minutes to try and get the buttons implemented, or did you finish that already? Maybe. Well, Adam, I'll give you another 5 minutes or so, or you can just let me know whenever you've got your on-screen buttons for the movement, and then yeah, go ahead and try and wire it up. Yeah, I'll give you another 5 or 10 minutes, and then we'll come back and go through it together. If you're still stuck.
How did you drag the player onto the on-click?
Oh, sorry, I had my microphone off. So inside of the button itself, you can hit the plus button. You can actually have multiple events trigger on a single button if you want, or have your functions call other functions. But basically, you select whatever button it is, and you hit the add button, and then you drag whatever game object it is that has the script that you want. So I dragged my player over here, and then when you hit the drop down, this is all of the components that are on that particular player game object. Notice that everything that's in our hierarchy is a game object. So you can call any of these. Everything is also a transform. Our player happens to have a mesh filter, a mesh renderer, a capsule collider, a rigid body, and our script, our move player script. And this is all of the functions that are in our move player script as well. And it looks like there's some additional ones that that we didn't write, but they're just kind of there by default. But I went over and I already added different move functions into the script just because before we were handling everything in update, but these buttons, you know, we need to know which button's doing what. And so I ended up writing 4 different functions for the 4 different directions. And then now these buttons can call those individual functions. And so we're going, whenever we push up, we're going to want to trigger the move up function. Does that make sense? Yeah, we're going to want to go over this again, I think, next class for the other students, just because, yeah, we covered this stuff a little bit, I think, 3 classes ago, but yeah, the heads-up display, the canvas, the GUIs, a large part of a game, right? A lot of times you have to hit a start button even to start a game, or at least pick, you know, if it's going to be single player, multiplayer, things like that. And so now, whenever I hit up, it should be triggering. I had the debugger going because for some reason it wasn't adding force when I did it. But it looks like part of the problem is it's not adding enough force. So it's doing it once, but this forward 8 is not really enough to get the thing moving. Now before we were doing it every frame, we'd have to hit the forward button really a lot in order to add enough force. If we come back over here,
well, I think the issue is that we can't hold the button, right?
Correct. So it's not on click then. I think there's another property probably in here. Yeah, we could either, you know, increase this to like 800, and this will almost certainly move us forward. Boom, we just ran into the wall. But you're right, the reason why it's not working very well is because on click only fires once, and we need something like on click down. Let me double check what it is. Unity on click down. It's called pressed. So we're looking for, here. Event trigger. That's our magic Unity component that we're looking for. So each button's got, some basic functionality, but really what we're looking for is the event trigger here. I think I even remembered to put event triggers on here, but I forgot to mention them when we were doing this example. But yeah, you are going to want to add an event trigger to this to the buttons as well, so that whenever you hold down the button, there's even additional functions in here whenever your mouse is over it. Yeah, we're looking for. There's even dragging and things implemented now. They're improving the event system of the UI canvas even still. Just because it's also relatively new. They didn't introduce the UI system, the canvas system, until Unity 5, which was just a couple of years ago. It's really looking for on press. Submit? No, it doesn't seem right. Pointer down. Yep. Yeah, this is more like when you hover over the button, when you leave the button and it's not hovering over, and this is when you are down. Click, I imagine, is just when it gets clicked. But yeah, this is the function that we want to use. And we're again going to call the up, move up. And I'm pretty sure we can turn this back down to 8 again. And our player will move appropriately now when we hold down this. It's still not giving it to us. Perhaps it's click. Rather than guessing, let's check the documentation.
So it sounds like you have to add 2 events. One is like on press and one's release. So you continuously set the force until they let go of the button.
Yeah, that would be another approach that would definitely work. I thought Unity would have something built in There's a lot of, so on pointer down occurs when we push down, and yeah, because I mean they have the same thing for key. They have on key and on key down. You'd think that they'd have something similar for their GUI system. I thought that's what the difference between on pointer down and on pointer click would be. But yeah, no, you might be right. We might have to set a flag for it. That just seems like a lot of work. I would think Unity would have something built in. Unity's got a lot of cool built-in functionality, and being able to detect if a UI button is down or being clicked is something I would think it would be able to handle. Ooh, there's also on select. Let's make sure that it's getting triggered. Triggers at once. Looks like it's selected now too. See how the button kind of changed colors? Looks like it's pressed. Well, we can even, rather than having the debugger go, we can add our debug code. This is kind of what debug code is for. Up, being pressed. So I don't know if it's because it's not compounding the force that we're adding or what. I mean, it seemed to work in the update, so let's go ahead and see if this triggers and fills up our console like we would think it would. Nah, it is. It's only being triggered once. So pointer down is not the one that we want here. Try this again. Definitely not that. Once something is selected, it can't be reselected, it seems like. You know, Taylor, you might be right. We might have to add an extra bool that keeps track if the pointer is, if it's down or not. That's kind of disappointing. I thought Unity would have.
Yeah, I was trying to trigger like a while loop that like delays every second, and it just checks to see put these Boolean flags. And it caused my Unity crash.
Yeah, you gotta be careful about setting loops that never end, or Unity will crash on you. I'm just surprised. I thought, yeah, actually, I don't use UI Canvas very much. When we've been working on Space World, we actually use an old GUI interface called NGUI. It's all right. At the time, it was the best one. The company, I think, ended up getting bought up by Unity. All right, just to get it working, let's go ahead and add that flag. So now, yeah, we're gonna end up having to write a bunch more code than I thought we were gonna have to write. So yeah, inside of our update now, we'll have a private tool called Appwrite. It's false by default. And inside of update, we'll have if Appwrite. Then we can go ahead and add an upward force. And now instead of move up, adding the force, we end up setting the move or up press to true. And then we have to write yet another function called up released. And then this sets up pressed to false. And yeah, that should work. It's more work than I thought it would be, though. I'm gonna look around and see if there's something on the forums. Maybe we weren't doing something right. Perhaps we're using the wrong event trigger. But even that seems to not want to work.
Oh, I know that it was hard, I think,
Huh. Let's go ahead and set another debug point here. Oh, we forgot to add the event trigger to the up button. That's why it wasn't working. Yeah, let's go ahead and add our pointer down. We're going to be triggering player. And it's going to trigger our move up function. And then again, if we have a pointer up, indicating that we released it, then we trigger the up released. And that should work. Yeah, it wasn't triggering because we didn't have our event triggers set. Now it looks like we are indeed moving. All right. So if we wanted the other buttons to work, we've really got our work cut out for us, right? We've got to write 6 new functions, add 6 new lines of code to update, and then go over to our editor and add those. Well, we've got about 4 minutes left in class. I'm not sure what else we would be able to accomplish. So let's just go ahead and see if we can pound that out real quick. Yeah, we already have these functions written, so it's a matter of also adding the variables. Cheat a little bit here. Copy and paste and get up, there, down, press, left, press, right, press. Hope everyone's able to follow along. We're just kind of writing code that I didn't think we would actually have to write, but we're doing it the hard way so we can get it working. Yeah, that's all the code we should have to write. Now it's just a matter of coming over to our editor and wiring up our buttons. Yep, just need that trigger. Pointer down, and we are going to mouse down, and again, pointer up, and we know that down was released. Left. Move left. Up. Released, down. It might look like I'm going fast, but it's a pretty repetitive thing to be doing. Down. So right. Release. All right. Go ahead and save our scene just in case Unity crashes. And
Yeah, I had it crash, and my whole scene didn't save for some reason.
oh
The scripts were all
no!
there though.
Yeah, I've learned that lesson before. That's why I save my scene before I hit play. So yeah, this is how this is working now. So yeah, we've got our kind of first-person, third-person controller. We've got thumps. We went over physics materials and things. See how when we're behind the wall, it turned black. That's another reason why the clipping plane is sometimes you want it out. See how it doesn't look very nice when it does that? That's why sometimes it's better to have the clipping plane adjusted for that. So we did go over some camera stuff as well. But yeah, I'll export this project, this Unity project, and I'll post it to the Slack as well, so that you guys have all this stuff. And I'll post the video as well. Do you guys have any questions? Otherwise, yeah, we'll reconvene again on next Tuesday. But yeah, if you guys have things specifically that you want to go over next class, or things that you're stuck on, yeah, any tutorial or something that you are working through this weekend and you get stuck somewhere, yeah, you can bring that to class next time. And yeah, if you're getting stuck on it, there's a good chance that somebody else is getting stuck on it, so we can all just kind of go through it together. You know, we're all basically, you know, learning together, and so yeah, just let me know. You know, I'll check the Slack too, if you don't want to wait until Tuesday. But other than that, yeah, you guys have a good weekend, and I'll talk to you. See you guys next week. Thanks.